Hello, welcome friends. Me Anila. The topic of my discussion is about numericals on failing test. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you about failing test and how to solve numericals related to failing test. This test is used to identify reducing sugars like glucose, fructose, lactose, maltose and aldehydes, but not sucrose because it is non-reducing sugar. Actually, glucose, it's a monosaccharide sugar containing aldehyde group. Lactose, maltose also contain aldehyde group, and also fructose containing ketone group and other aldehydes all are detected by this test, but not sucrose because sucrose does not contain free aldehyde group. So in this test we identify these reducing sugars. Procedure. Fehling's A solution is composed of copper sulfate solution blue, and Fehling's B contains potassium sodium tartarate with sodium hydroxide. So this test consists of Fehling's A solution, which is copper sulfate solution blue, and Fehling's B containing potassium sodium tartarate with NaOH, that is basic medium, strongly basic medium. In this procedure, we have to add equal amounts of Fehling A and Fehling B, add sample, that is a reducing sugar sample, and heat gently. Equation. So this test is for reducing sugars. I am taking an example of glucose. This is molecular weight of glucose, molecular formula of glucose C6H12O6 plus this is molecular formula of glucose plus Phenyl A containing copper sulfate. We are writing here copper 2 plus because copper is in plus 2 oxidation state in basic medium 5OH negative, that is strongly basic medium, produces C6H11O7 negative. This anion is carboxylate ion plus Cu2O, that is copper oxide, copper 1 oxide plus 3 water molecules. So in this reaction, glucose is oxidized to carboxylate ion and copper 2 is reduced to copper 1 oxide. This is oxidation reduction reaction, that is redox reaction, and 1 mole glucose produces 1 mole copper oxide. This is the mole ratio between them. Now, initially the copper solution is blue because it contains copper sulfate, and after the reaction solution becomes brick red because of copper 1 oxide. Observation. Blue color remains the same, means negative test, no reducing sugar present. Brick red precipitate form means positive test, reducing sugar present. So if the test is negative, blue color remains the same, no reducing sugar present, no glucose or fructose present. If brick red precipitate are found, means test is positive and reducing sugar like glucose, fructose, maltose, lactose are present. So this test is used to identify reducing sugars and aldehydes, etc. Example number 1. 100 ml of glucose gives 14.3 gram copper 1 oxide. Calculate molarity of glucose. As I have told you earlier that glucose, 1 mole glucose in the equation in previous slide 1 mole glucose produces 1 mole copper 1 oxide. By this mole ratio, we can calculate molarity of glucose. Mass of copper 1 oxide is given. Volume of glucose solution is given. Solution. Copper 1 oxide molecular weight. First we have to find the molecular weight of copper 1 oxide is equal to 2 is the number of copper atom into 63.5 is the atomic weight of copper plus 1 is the number of oxygen atom into 16 is the atomic weight of oxygen. After solving, molecular weight of copper 1 oxide is calculated to be 143 gram per mole. Now we have calculated molecular weight of copper 1 oxide. Now we will calculate moles of copper oxide. We will apply the formula amount over molecular weight. That is, amount is given in the example. 14.3 gram divided by 143 gram per mole is equal to 0.1 moles. So moles of copper oxide are calculated to be 0.1 moles. Now we will, because we have to find moles of glucose, molarity of glucose, so we will apply mole ratio. 1 mole copper oxide is formed by 1 mole glucose. So 0.1 moles copper oxide is formed by 0.1 moles glucose. 100 ml solution contains 0.1 mole glucose because we have to find molarity of the solution. So molarity is in 1000 ml. So 1000 ml solution contains, we will multiply 0.1 by 1000 divide by 100, we get 1 mole glucose. So molarity of glucose solution is calculated to be 1 molar. Example number 2. 20 ml of glucose solution is diluted to 100 ml. From this diluted solution, 10 ml produces 5 gram copper 1 oxide. Find the original molarity of glucose. So again, the Fehling test reaction is occurring. 20 ml of glucose solution is diluted to 100 ml, that is 5 times dilution. From this diluted solution, 10 ml of glucose solution produces 5 gram copper 1 oxide. We have to find original molarity of glucose. Solution. So, mass of copper 1 oxide is equal to, we will apply formula. First we have to find molecular weight of copper 1 oxide. Molecular weight is already I have calculated earlier 143 gram per mole. Amount of copper 1 oxide is given. We will apply mass of copper oxide is equal to 5 gram divided by 143 gram per mole is equal to 0.0349 moles. We will apply mole ratio. 1 mole copper oxide is equal to 1 mole glucose. So 0.0349 moles copper oxide is equal to 0.0349 moles glucose. Because that much glucose is present in 10 ml, that is 10 ml contains 0.0349 moles glucose. So because we have diluted the solution, so 100 ml contains 0.349 moles glucose. Because the actual volume is 20 ml, 20 ml contains 0.349 moles glucose. So we have to find molarity. So 1000 ml contains, we will multiply 0.349 with 1000 and divide by 20, we get 17.45 moles glucose. So the molarity of original glucose solution is calculated to be 17.45 molar. So in this way, different types of glucose, fructose, reducing sugars, aldehydes are detected by Fehling's test, and we can calculate mass of glucose that is reacting. Friends, If you have any question, you can ask me on comments. I can help you. Thanks.